Hi, this video is to talk about interval estimation. That's our focus on chapter 8, and I'm going to start talking about margin of error and confidence level. These are two new concepts you must understand. But before I talk about that, let me tell you what we are doing in this chapter. We'll discuss what an interval estimate is, and we're going to use sample data and a confidence level to come up with a margin of error to our mean. Let's understand a little bit more about that. Remember that in chapter 7 you learn about point estimator. So a point estimator is, for example, a sample mean is a point estimator for a population mean. I want to know how the population mean is, then I use a sample and I get a sample mean, which is a point estimator for the population mean, okay? So, however, this is the problem. A point estimator cannot be expected to provide the exact value of the population mean. Remember, when we're trying to estimate the population mean for the AI example using sample data, we get a sample mean that is somewhat close to the population mean, but is not exactly the same. Why? Because interval, this is the reason, okay? Because we're using samples, so it's not possible to have exactly, find exactly the population mean using a sample. It's gonna vary, okay? This is the reason we build an interval. This is the reason we have an interval estimate, which is an interval with a minimum and a maximum values, minimum and max values, and that's similar to the lower and upper levels in our distribution. Remember the lower and upper levels? That's what we're doing. We're building intervals that has a given probability of including the true population mean. Okay, so we're gonna build an interval estimate that has a given probability of including the true population mean. The true population mean we don't know. We don't know what is the true customer satisfaction of all customers in a given store. We don't know, let's say, the number of people that is overweight or something in the population. We don't know the exact height of all people in the population, but we can we can use a sample and build an interval to estimate with a given probability what this true population mean would be. Okay, and to do that, we're going to use the empirical rule, and we're going to have a confidence level and an alpha level, and we're going to use our z-scores. Okay, so remember the empirical rule from chapter 3. What the empirical rule is saying is, if you have a normal distribution, at the center you have the mean, and plus and minus 1 standard deviation, you have 68.3% of all values in the distribution, plus 2 and minus 2 standard deviations, you have 95.4% of all values in the distribution, and so on. Okay, so we're going to use this concept to build intervals, okay, which has a mean at the center, and then two a lower and an upper limits that we're going to use standard deviations of the sample mean, which you learned in chapter 7, to build this interval. Very similar to what you did in chapter 7, but we're going to add some additional elements in a very like more non-mathematical way. An interval estimate is the point estimate, the sample mean. Let's say we want to build an interval estimate for the population mean. So we collect a sample, and then we estimate the sample mean. We estimate this the mean, which becomes our sample mean, which is our point estimate. So this is the sample mean, and we add and subtract some error. Okay, very similar to this concept here. We have the mean. This is not the sample mean, this is the population mean, but let's assume that's the sample mean. So you get the sample mean and you add and subtract a margin of error. So you give some room for error in your attempt to estimate the true population mean, which we don't know. Okay? So in order to develop an interval estimate of a population mean, the margin of error must be computed. And to do that, we need the population standard deviation. And if we don't know the population standard deviation, we're going to use the sample standard deviation. Later, I'm going to show you how to do that. Okay? Let me, the idea is that as we build an interval for the mean, our interval includes the true population mean, which again, most of the time we don't know. Okay, that's the concept, that's the idea. The interpretation is this. Because 95% of all the intervals constructed using the sample mean plus and minus 1.96, this is z-score multiplied by the standard error. So you learned this in descriptive statistics chapter 3. This you learned in chapter 3 or chapter 6, the z-scores, and this you learned in chapter 7. So we're going to use all these elements to build an interval. We're going to add and subtract, let's say plus and minus 1.96 will contain the population mean. Okay, where is this 95% coming from? Remember the empirical rule? 95%. So the empirical rule says that if I get this sample mean, or in this case the population mean, and I add 2 standard deviation and subtract 2 standard deviation, I have 95% of all observations. So what we're saying here is if we get the sample mean, not the population mean, in this case sample mean, and we add and subtract almost 2, it's not exactly 2, is 1.96. To be able to get 95 is not exactly 2, is 1.96, and then we multiply by the sample standard deviation. Okay, so very similar to this concept, plus and minus 2 standard deviation, plus and minus 1.96 standard deviation. Okay, so when we do that, we say that we are 95% confident that the interval built using this process includes the population mean. Okay, this is what we say. Let me give you some examples here. If a marketing poll suggests that the 90% confidence interval of people buying a particular product is between 24.2 and 28.2, it means that the interval between 24.2 and 28.2 will include the true population mean 90% of the time. So we are trying to understand how much people spend so we can plan our sales, plan our operations. So this is how much, this is the interval that will include the true value about how much customers purchase 90% of the time. This means that if we build 100 intervals using the sample data, 90% of these intervals will contain the true amount that customers spent on our store. Because of that, we say that we're 90% confident that our interval will contain the true population mean. Let me show you one example in MindTap. Again, MindTap is really good because it gives us some nice applets to visualize. So we are in chapter 8, and in chapter 8 we have chapter 8 exploring statistics, and here in exploring statistics we have competence interval and sampling. First one. So this is a distribution. Let's say that this is I don't know how much. Let's say this that information here. Blah blah blah. Okay, let's say that this is the population mean. I know that is the population mean because it has a Greek letter mu. So let's say that 80 is the grade for students in business statistics. Okay, so that's the true mean for all classes in the United States that teach business statistics. But I don't know that this is the true mean. We never know. But we're just playing with the idea that we know, just for you to understand what the building confidence intervals mean. So you see that I collect a sample of, I don't know, 100 students in South Carolina or the entire United States, and then I get an interval between 74 and 82. To simplify, let me skip the decimals. So the interval from 74 to 82 with 95%, I can say that we are 95% confident that this interval between 74 and 82 include the true population mean, which is the mean grade for students in business statistics in the United States. Okay, so how much is the sample mean for this interval? 78. But 78 is not exactly 80, but the interval contains the 80. So my interval will be correct 95% of the time, or if I collect 100 samples, 95%, 95 of them will have an interval that contains the true population mean. Let's get another sample so you can see. Look, another sample. Now the sample mean is different, but the interval contains the true population mean. If I keep doing that, I get to the point in which I have a sample that has an interval that does not contain the true population mean. So in this case, I'm going to be using information that is not correct, because it's not including our interval based on a sample data, is not including the true population mean. Let's take a look at if we have 100 samples. This is a simulation if we have 100 samples. If we have 100 samples, 4 of them do not include the true population mean. So in 96 of them, this is more than 96 is more than 95. Our sample includes the true population mean. So this is the idea for building intervals. We don't know what the true population of something is, and we want to estimate and be confident at a certain level that our sample contains the true population mean. Okay, so this is what we are doing. We did that. We see this applet. Here's another example. If a supply chain study suggests that 95% confidence interval of the lead time of ships arriving from China to Charleston port is between 28 and 34 days, it means that if the study is conducted using the same technique over and over, 95% of the time, the interval between 28 and 34 days will include the true value, the true population mean, which is the lead time of ships arriving from China to Charleston port. Or in other words, we are 95% confident of the shipment time be between 28 and 34 days. This is very important because if you want to plan operations in the port, we know how we have a confidence in the interval that those ships coming from China will take to get to the port. Okay, I'm going to stop here and prepare another video about understanding margin of error.